Today we're looking at linear functions. So we need to find the slope and y-intercept for this line, graph it, calculate its average rate of change, and determine whether it's increasing, decreasing, or constant. So this function is written in slope-intercept form, which we more traditionally know like this: y equals mx plus b. We know that f of x is just equivalent to y, so we can still find all the information that we normally can using slope-intercept form in this form as well. So that means that the slope, right, our slope is still 2 because it's just the value in front of x. It's our value of m. And then our y-intercept is the value of b, which in this case is -1. So m is 2 over 1. That's our slope. And then our y-intercept is the ordered pair 0, -1. So we have our slope, we have our y-intercept. So we can use that information to graph our equation. So first we plot our y-intercept, 0, -1. And then we use our slope of +2 to go up 2, right 1, up 2, right 1, up 2, right 1. Or we could use down 2, left 1, because those are both negative, and a negative divided by a negative is going to be a positive value. So we could plot all of those points and then go through and just draw our line. So we have our straight line here. This is the graph of f of x. So there's our function there. So we are then asked to calculate the average rate of change. The average rate of change, if we remember from before, is the change in y over the change in x of a secant line that intersects our curve. But since this curve is just a line, the average rate of change for a linear function is actually just the slope. So this is actually just the slope. So this is the equivalent to the slope of our line, which we know is 2 over 1. So the average rate of change for f of x is 2 over 1. And then we have to figure out, is this function increasing, decreasing, or constant? If our function has a positive slope, it will be increasing. If it has a negative slope, it will be decreasing. And it will be constant if our line is horizontal, meaning that the slope is never changing. So we can see that our function is increasing. It's going up from right to left. It has a positive slope, so we know that it's an increasing function. So let's take a look at another example. So we have this graph here. F of x equals -2/3 x plus 1. So again, we need to find the slope and y-intercept. So our slope, just like before, is -2/3 here. That's the value of m. And our y-intercept in this case is +1. So we have m is -2/3, and then y-intercept is 0, +1 this time. So again, let's graph it. So we plot the y-intercept and use our slope to find some other points. So the y-intercept is up here at +1. And then we can use the slope to go down 2, right 3, down 2, right 3, down 2, right 3, or we could have gone up 2 and left 3 and continue that pattern for a little bit, and then draw in our line. So this will be our line here. So this is our function f of x. So again, the average rate of change is just the slope. So here it's -2/3. The average rate of change is just the slope of our line. And then for this one, is our function increasing, decreasing, or constant? Well, you can see that as we move from left to right, that our graph is trending downward. Also, our slope is negative, so that means our function is decreasing. It's a decreasing function. So when you're looking at graphing a line, we know that we need to find the slope and y-intercept. The average rate of change, again, for a line is just the same value as the slope. And then to figure out if a function is increasing, we look at its slope. If it's positive, it's increasing. If it's negative, it's decreasing. And if it's 0, meaning it's a horizontal line, then it has it's constant.